are continuing to talk about the normal distribution today. We looked at it yesterday with just some very basics. What does the graph look like? How do you find mean and standard deviation? What we're looking at now is actually calculating probabilities from it. If you look on your formula sheet, we do have the third page is a table for the standard normal distribution, so we will be reading numbers from that today. So flip to that part of your formula sheet. The big piece that we need today is a formula for converting everything in terms of the same units. When we are talking about a normal variable, you can take any variable that's normally distributed with a mean of mu and standard deviation of sigma and get a z value. This z will convert it in terms of a mean of 0 and standard deviation of 1, which will allow us to then just read it from a table. So basically what we're going to do is take any value that I might give you. We're going to convert it in terms of a z. So that's like with a mean of 0, standard deviation of 1. And then we can use our normal table to calculate our probabilities. If you look on your formula sheet, we're in Chapter 7. Chapter 7 has the z formula right there, so it is all given to you. But that will be our first step on every single problem, converting it to a z.
The Chapter 7 looks pretty short.
It is. This is our last section that we're covering.
For the whole year?
Wasn't that a test?
For the whole semester?
Yeah, we're going to go to Chapter 7. We're going to Chapter 8 now.
Oh,
Okay, you made it sound like this was our last
I said of Chapter 7.
I know, but you like the way you said it at first, like I was like,
Sorry.
oh.
Big brain.
Okay. So, does everybody have your z formula down? That's what you need. Z is x minus mu over sigma. When you look at this table, everybody look at this real quick. It's got a diagram at the top. The table gives you the area to the left of a specified value. Okay, so if you're looking at it, it'll always give you the probability of being less than that number. So if I wanted the area to the right, if I wanted the greater than, we'll have to do 1 minus to get that. Okay, so just keep that in mind. Let's look at a problem. Let me give you a second to write this down before I work through it. Are normally distributed with a mean of 100 and standard deviation 15. Find the area to the left of a score of 120. If you just went to your table, does it have 120 on this table? No. That's why we have to convert it to a z value. So, to find our z, z is x. What's my x value? 120. Minus the mean over the standard deviation. Just go to 2 decimal places. That's really all we need. You get 1.33. So then you go to your table. So that's my z. I'm looking for a probability of being to the left of that. So you go to the 1.33. So you have 1.3 on the side of the table, and then you have to go to the 3 on the top. And make sure you're looking so you know if you need help reading this table. And what do you get? 0.9082. Okay. Let's talk about this real quick and make sure we know how to read the table.
Oh, I was in the negatives.
Yeah, you have to watch your positives and negatives. So I'm going to 1.3. That is extremely blurry. And then across the top you have the 0, 1, 2, 3. So it's right there, the 0.9082. Does everybody see that? Okay. So that is the area to the left, or the probability of having a score of 120 or less. So how would I find the area to the right?
1 minus 1.
Mm-hmm. Get 0.0918. Questions there? Okay, I'm going to put up a few and we're just going to practice reading from this table. So I want the area under the standard normal curve to the left of, so if you're writing this down, I would just do like just this. So left of z equals negative 0.38. So I already gave you the z value. We don't have to do the formula. Go to your table. Negative.
Negative 0.3, and then you go to 0.08.
Mm-hmm.
Like, I get, I just don't know why.
Well, because
Like, this
so
is like,
this is like the nearest tenth, and then this tells you that's the nearest spot. So what'd you guys get? 3, 5, 2, 0. Everybody see that?
What'd you get?
like 35 that you said.
All right, so area to the right. How do I find area to the right? 1 minus, so I go to my 1.25 is 0.8944. So 1 minus that. Okay, 0.1056. The third question says between two values. So let's just jot down for a second. If z is negative 1.02, what value do we get from the table? If z is 2.94, what do we get? So to be between those two values, if you think about what this means, so negative 1.02, that's telling me this area down here. The 2.94, what we found is all of this area. What I want is just this part. So what do I need to do with those two numbers?
Subtract
0.9984 minus the 0.1539. So if you want between two things, you just have to subtract them, and we get 0.842 or 844. 5. What you guys got? Any questions about how to read this table? Those are really the only three types of questions I'll ask. To the left, to the right, or between two numbers. To the left, you just read it. To the right, you do 1 minus. Between, you do the big minus the small. problems. A pediatrician finds the heights of her female 3-year-old patients are normally distributed with a mean of 38.72 and standard deviation 3.17. Part A. Find the proportion of 3-year-old females with a height less than 35 inches. So I'm asking you to find the probability that X is less than 35.
So I get 35 minus 38.72 divided by.
We can't read the 35 from the table, so we have to translate it into a Z first. So to change this to a Z, you do X minus your mean over your standard deviation. And we get calculate Z is less than negative 1.17. So if you read from your table,
0.0384.
you're at 0.1210.
I had negative 1.77.
Oh. Did you guys get that? What?
Yeah, it's a 0.
What's a 0?
0.1210.
Oh, thank you. Yep. Not sure where I got the 7 from.
Probably because I said.
Probably because you said a 7. Is that one alright?
Do we need to know how to find these without the chart?
No. Alright, so B, find the probability that a randomly selected 3-year-old is between 35 and 40 inches tall. Okay, you can use it in this notation. You don't have to. And actually on these, it also isn't going to matter whether these are equal to's or not. The probability is the same. So we need to find the z's for both of these. We already know it for the 35 though, don't we? Okay. So I'm going to write this out. If you use this notation, you have to convert both of them to z's. So X minus the mean over the standard deviation. So you get your z's, this is negative 1.17, is less than z is less than 0.40. So how do you find the probability that it's between two things? Subtract them. So the bigger one is going to be the 0.4. So let's read the probability of 0.40 is 0.6554 minus the probability of negative 1.17, which we know is 0.1210. So we get 0.5384.
Oh, we're done.
Mm-hmm.
When's our test?
We just started this chapter. We'll have a
I mean, the
quiz.
quiz. I mean,
hopefully, today's Tuesday, Friday. This Friday.
So we're gonna quiz on Friday?
Is this one all right? Thursday or Friday, I guess we may have one. Okay, I'm actually going to skip this. All right, let's look at this example. The combined verbal and quantitative reasoning score on the GRE is normally distributed with a mean 1,049 and a standard deviation of 189. What is the score of a student whose percentile rank is at the 85th percentile? Okay, this is different. And you may give you a second to write it down or jot down some things. I want to jot down your mean, standard deviation, and then your question. I gave you the percentile. If you take a test and you score in the 30th percentile, do you know what that means?
Score better than 30. Score better than 30.
Right, you scored better than essentially that 30%. 30% of the scores were below you. So the 85th percentile, that's not my X value. That's my probability. So in other words, if this is the 85th percentile, that's like saying the probability that somebody was below your score was 85%. So that's 0.85. That's your area in the table. We need, if we're going to use anything, we're trying to find your actual score on here. We're trying to find X. So if our probability is 0.85, we need to find out what Z value that corresponds to. So the 0.85 is not the number on the outside of the table, it's the number on the inside. So you have to look inside the table until you find 0.85, or at least as close as you can get. So the closest we can get.
0.8508.
If I'm looking, I'm trying to find 85% in here. And so I see that's kind of right in here. I have 0.8485 and 0.8508. Which one's closer? 0.8508. So that's at 1.04. So this means my Z value is 1.04. Our whole goal here is to find X. So we have to use our Z formula. Z is X minus mu over sigma. My Z was 1.04. My X I don't know. The mean was 1,049. Standard deviation is 189. Multiply over. So I get 1,245.56. We're talking about a test score here. This particular test, you actually can't get a decimal. So if you told me you got about a 1,246, that would be fine. So this one we had to work backwards. Any questions there? Let's look at another one then. It is known that the length of a certain steel rod is normally distributed with a mean of 100 centimeters and a standard deviation of 0.5 centimeters. So I know my mu and my sigma. Suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the length of rods that make up the middle 90% of all steel rods manufactured. The middle 90%, so we've got a normal curve. I want the middle 90, so this part is 90%. So what's this represent? And this would be. You guys agree with that? Alright. So we are trying to find x again. So we're working backwards from the table. This first one, area to the left would just be 0.05. So this first one, the probability is 0.05. So we have to find the z that corresponds to that. So if I'm looking 0.05,
05, like 0505.
yeah, I've got 0.0505 and 0.0495. They're the same distance away, aren't they?
Yeah.
So this happens at negative 1.64 and negative 1.65. Can we just go with the middle then? Agree, since they're the exact same distance away, it would be in the middle. What falls in the middle of negative 1.64 and negative 1.65? Negative 1.645. Z equals. Okay. So in this scenario, can we find the length that goes with this? So Z equals x minus mu over sigma. So my Z, negative 1.645, equals the x I don't know, minus 100 over 0.45. So multiply over the 0.45, add over your 100. And then 9.26. So that's the small length here. That's the smallest it could be in this scenario. I still need to find this length up here, don't I? So we're going to go through the same process. Our P. P is area to the left. If there's 5% to the right, how much is to the left? 95. So find your Z. So you're looking for 0.95. Okay, we see the same thing. It's exactly in the middle of positive 1.64 and negative 1.64. So we're going to go with 1.645. So then we do our formula. Z equals x minus mu over sigma. I get 100.74. So the question was, what length of rods would make up 90%? So anything between 99.26 centimeters and 100.74 centimeters. That is the range where 90% of the rods are going to fall in between those two numbers. Questions? thing I want to talk about is the notation. There's what's called Z alpha notation. And for whatever reason, I didn't design the notation, but it's kind of the opposite of how we read things on our table. Okay, so if you have Z sub alpha, you see that? That's talking about the area to the right. So the table gives you area to the left. But if I ask you for Z sub 0.2, I'm asking you for the area to the right of that number. So you want to jot this down. You can draw yourself a little picture too. This shows you the notation. And then we're going to try an example. I want to find the value of Z sub 0.10. There are two ways of doing this. In this notation, alpha represents the area. What this means is I want the Z value so that 10% of the area is to the right. So if you draw your little picture, it's saying this area is 0.10. Tell me what Z equals. Tell me any thoughts you have on how we could get that.
So is it 1 minus 1 0 in here? So 0.10 is 0.5398 would be 1 minus that.
Except, okay, you're correct on the 1 minus, but this isn't the number on the outside, the 10% is on the inside. So remember, the table gives you the area to the left, right? So if I want to look it up in the table, I have to know the area to the left.
It's like a
If this is 10%, then my actual area to the left is 90%. So I am looking on my table when my area is 0.9. So you have to look inside the table.
The 0.8997 would be closest. Because the other one is 0.9015. That's 15.09.
Yep. So closest we can get to 0.9 is 0.8997, and that happens when Z is 1.28. I'm going to give you guys another one of those. So I want you all to find Z sub 0.85. 85% of the data should fall to the right. So can you tell me right now, is your Z going to be a positive or a negative? Negative, because right here in the center, that's when Z is 0. So this would be a negative. Okay, if 85% falls to the right, what falls to the left? 0.15. So you're looking inside your table when your P is 0.15 and you get Do we need another one? If there aren't any questions, this is my stopping point today. Here is the assignment. It is due Thursday. I may do some more examples with you tomorrow, but you will have at least part of the class to work tomorrow. So you can expect to have some work time. You may do a little more practice